Hi guys, welcome to this set of videos, and all of these videos are going to follow along with the notes out of your guys' book that go with Chapter 6, Section 4. And what we're really kind of doing here in this chapter is we're taking a look at some of the algebra that we can do with radicals. So what we're going to begin to get into here in Section 4 is really kind of continue working with simplifying radicals. But what we really want to talk about now is more than just the square root, right? There are radicals of greater degree, and so essentially what we're going to be doing is talking about nth degree radicals and some sort of techniques you can use to simplify those radicals. So before we do that, let's just go ahead and get some objectives or learning targets. These are things that you should keep in mind as we go through the notes. This is what you need to be able to do by the time we get to the end of this set of videos. So let's go ahead and highlight them for you. I've got them right here. First, you'll need to be able to simplify radicals, and we'll again give you several different techniques to kind of help you simplify radicals. And then you'll need to be able to use your calculator to approximate radicals. Now, the calculator that I'm going to be using, sort of the directions in the sequence of buttons that I'll give you, is going to be for the TI, Texas Instrument, graphing calculator, the TI-84. Other graphing calculators, other calculators will handle solving radicals or simplifying radicals or giving you the decimal approximations of radicals, but really the one that I'll be giving you, sort of showing you how to use, talking to you about how to use, will be the TI-84. If you have another one, just use the owner manual that came with it, or check out a YouTube video and find out exactly what functions your particular calculator has and how to use it. So let's go ahead and jump right into this. What I have for you here is an example of a formula, actually, that gives the volume of a sphere. So this is for the volume of a sphere. And the reason that I give you this example to get us started is because it is a perfect example of an nth degree radical. Now, you guys are very familiar with square roots, but you probably haven't had to deal much with radicals that are of greater degree than the second degree, which is the square root. So what we've got here is a cubed root, actually, in fact, and we know it's a cubed root because my index is a 3. So let me go ahead and give you just a couple of quick notes about this particular formula and radicals in general. First of all, like I said, this is a third root. Oh, I apologize, that's my highlighter. One second. This is a third root. And again, the reason that I know it's a third root is because the 3 here outside of my radical is not a power. Actually, what that's doing is indicating to me which degree root I will be taking. We always call the number in this position, we give it the general symbol n, which we'll get to in just a second. So anyway, I'm going to use that particular terminology here, and we're going to say that n is called the index. All right. Now, when it comes to the index of a radical, 2 is what's implied. So if I just write a square root, right, the index is going to be a 2, but I don't have to write it because that's implied. If the index is ever anything besides a 2, then I'll have to tell you what that index is, and I'll do that by putting whatever degree root I want you to take right there in that index spot. A couple other things here for you. So in this case then, in our particular example problem, the index is 3. That's how I know I am taking a third root. Okay, now, what we're going to be doing then is this, and there's a couple of things that we'll look at here when it comes to simplifying, but I just want to mention a couple of these right now. And first is this, a couple of examples for you. If the index, right, the degree of the root that you're taking, and the power underneath the radical symbol, if those are ever the same, they'll cancel each other out. Let me show you exactly what I mean. It's actually very, very simple. If you have an x squared, and I'm going to take the square root of x squared. Now, remember, when it comes to a square root, when the index is a 2, we don't write it. It's implied, right? So I'm not going to write it. Your book won't write it. I won't write it. You shouldn't write it. It won't be on the homework, won't be on the quizzes, right? Nobody's going to write a 2 there. You just need to know that if you don't see anything in the index spot, that means it's a 2, in which case we're taking a square root. The point here is this, though, when it comes to simplifying, and this is really going to kind of be our goal. If I can get that index and the power under the radical to be the same, as long as those two numbers are the same, then they'll cancel each other out. And this whole thing would just be an x, right? Because what undoes a square? Well, a square root undoes a square, or vice versa. Squaring something undoes a square root, right? So if you can get the index and the power to be the same, they'll cancel each other out. It's not just for square roots. What if I were taking, like we had above, a cubed root of an x cubed? Well, again, as long as the index and the power are the same, they'll cancel each other out, right? Same thing if I take a fourth root of something to the fourth power. Again, as long as the index and the power are the same, they will cancel each other out. So then let me give you kind of like a little sneak peek then of really what we're going to wind up getting to here on the next couple pages, the notes when it comes to simplifying, is if I were to give you something like this. If I were to give you the square root, but initially the index and the power don't match. Here's a great example. I'm taking a square root where the index is a 2. It's not written. You need to know that it's a 2, right? So if nothing's there, it's a 2. But I'm taking the square root of something to the fourth power. Now, my index and my power don't match, right? And so really what we're going to kind of do here over the next several pages is kind of figure out how you would go about taking care of this guy. And it's actually very, very simple. All you would simply do is recognize that I can split that x to the fourth up into an x squared times an x squared. And then the product property of radicals says, hey, because those guys are multiplied, I can split it up into the square root of x squared times the square root of x squared. And now the index and the power are the same. They'll cancel each other out, and we begin to simplify more complicated radicals. So that's really sort of what's going to be coming here in the next couple of pages as we look at simplifying. Radicals. But before we get to that, one other quick couple of things to go over here with you, and it's going to be this, the way to think about these radicals. So what I'd like you to do is I'd like you to find the cubed root. The cubed root, I know it's cubed because my index is 3, so the cubed root of 64. Which means what you're trying to do is you're trying to find a number, let's call that number a, such that if a cubed, it would be equal to 64 if you were to cube a. Let me show you exactly what I mean. Here's how it works. If I'm taking the cubed root of 64, and that's equal to some number a, equal to some number a. Well, all I need to do, right, all I need to do to get rid of the cubed root is take and cube both sides, right? So if I were to cube the cubed root of 64, well, now the index and the power are the same. They'll cancel each other out. But algebra says whatever you do to one side, you have to do to both sides. So I would also have to cube the a. Now, because the root, the index and the power are the same, the root goes away, and I'm left with 64 is equal to some number a that is cubed, which is exactly what I've given you right here. Well, what number, when you cube it, gives you 64? And of course, that would be a is equal to a 4. If you take 4, raise it to the third power, you're going to get 64. So we know that a would be equal to 4. Therefore, the cubed root of 64 would be 4. All right, same thing down here, right? I'd like you to find the fifth root of 32. Well, here's the way that's going to work. I have a fifth root of 32. I know it's a fifth root because my index is a 5. That's all equal to some number a. I'm trying to figure out the fifth root of 32. Well, again, in order to get the root, the radical, to go away, I just need to raise it to that power. So we're going to do the fifth root of 32 raised to the fifth power. But algebra says whatever I do to one side, I have to do to both sides. The index and the power are the same. They'll cancel each other out. And I get 32 is equal to some number raised to the fifth power. Well, it won't take you very long to figure out that the number raised to the fifth power that gets you 32 is 2. So a would be equal to 2. What that means is if you were to take the fifth root of 32, you should get 2. Now, here's the way that that's going to work on your calculator, because your calculator can handle larger degree radicals. Essentially, again, if you're using the TI-84, it's going to be under the math function. On the far left-hand side of your calculator, there'll be a button that says math on it. You'll go into that math table, and I believe it should be either option number 4 or option number 5. I think option number 4 is actually going to be a cubed root. You'll see right in there. It'll show you a cubed root. You just hit cubed root, then you can enter whatever you want to take the cubed root of, and your calculator will take care of it. If it's something other than a cubed root, some higher degree than a cubed root, I believe it's option number 5. It's the one either right above it or right below the cubed root under that math function. Where it'll be any. You can change the index, right? So it'll allow you to put it in your calculator such that you get to select what you want the index to be. In this case, I want it to be a 5, and then you can figure out what you want your radicand to be. What are you taking the radical of? And in this case, it would be a 32, and then your calculator will go ahead and calculate the fifth root of 32 and give you a 2 back. So head on over to the next page of the notes. We'll begin to take a look at simplifying some of these radicals, and I'll meet you over there.